I see. I see. So that could be it. So that's a great point, that some of this, the observations here are missing because people leave the sample. And like, there's no way for all of Isaac's connections he could get your test score in Los Angeles. So, okay, that's really great here. So I think some of the speculation we have that makes sense. That at least for some of the high-scoring national school kids, any residential mobility by their family would drop them from the sample. So we're not going to have 100% graduation. That's not a mark of failure. And in part, if it is the very strong students who are moving, then this pattern can make sense. Okay, very cool. I love that. That was so cool. Thanks. Okay, so the next one, I put more of the kind of labeling on this one, is maybe the outcome that we find more useful, and this is the test score outcome. And maybe this is where we expect to see a little bit more action. So there's a couple patterns here. One thing you see is there's an upward sloping relationship between your test score at baseline, the KCPE exam, and how well you do on the KCSE. And they've normalized the KCSE to be in these sort of standardized units that we were talking about with the e-learning study or the Girls Scholarship Program, where the mean is 0 and the standard deviation is 1. So you can see even these guys here, all the way to the left with minus 30, have really good test scores. They have a 1.5 standard deviation test score. That means they are, on average, 1.5 standard deviations above the mean KCSE score. So these are very good students. This whole sample are like very strong students, but it's very strongly upward sloping. So when you get to the folks with the plus 30, they're already at 2.5 standard deviations above the mean, which is really in the tail of the distribution. These are the very strongest students. So the slopes on both sides are very similar. What's different from the previous plot is if you look at the discontinuity, I put the arrow there again, now there's no jump. So even though we know there was a jump at exactly that point, these are the exact same kids as that previous plot, we knew there was a jump of 50 percentage points at exactly that point before. Having a 50 percentage point higher likelihood of attending a national school does not increase your test score. Here. It's just a 0, a straight up estimated 0, just a smooth line. So this is really striking. Yeah?
How equivalent are the skills tested in the KCPE to the KCSE? Like, I feel like we're almost comparing.
They're both standardized academic tests with lots of the same subjects, actually. So the core subjects on the KCSE are also among the core subjects on the KCPE, English, Swahili, mathematics, etc. So, it's they're developed by the Ministry of Education, by the same sort of expert groups on testing. They're pretty comparable. Obviously, the KCSE is much more advanced because people have taken high school math, but they're the same system, the same test makers. So, it's not really an apple. I don't think it's an apples to oranges comparison. David?
I was just going to say, it doesn't necessarily, it's just showing your ability, because there's jumping your ability to do well on this test, which might not necessarily mean in terms of actual learning. So isn't there like 2.6 as many subjects in times as other schools? So
Yeah.
in that case, maybe this test probably doesn't go into those subjects at all. So
the KCSE, you have to take, I think, 9 subjects, I believe, and you have to take a certain number of science, humanities, etc. And what being in a national school gives you is, maybe in the national school you go to, so let's say you have to take 2 science classes. Maybe in the national school you go to, there's biology, chemistry, physics, something else. So you get to choose 2 out of those 3 or 4. But if you're in a provincial or district school, they just have 2. They're like, look, we have enough facilities to do chemistry and biology, and that's it. And so if you just happen to be a genius in physics, you just don't have a chance to even take the test because you're not being taught those materials.
So it should be different if in your day you're taking 3 subjects in a day or 5 math.
No, that's right, because everybody's going to be preparing for a certain number of exams. But in the big national schools, you have more choice. So you would think almost mechanically you would see a jump there because people could kind of sort into subjects where they're better. And you're not. So the national schools offer French and German and all kinds of foreign languages again where you could choose among them. So it's kind of surprising actually because you would think that these greater opportunities would allow you to pick subjects you're good at. I was good in physics, but I wasn't that great in biology or something. So if my school was only good at biology, I wouldn't have done as well. Something like that. Yeah.
So they compare the national schools to the average all secondary schools on quality.
Yeah.
It seems like if people just below the threshold, you're not going to the average non-national school.
You're right. It's not really a fair comparison in some ways what they did in that introductory. They have this sort of like background section and they do contrast at various points like all secondary schools with the national schools. But what we want to do is create data, get the data which they have on exactly which provincial schools you attended and create the averages for that set of schools for the people like here, right? So maybe it isn't 2.6 subjects, maybe it's 0.4 of a subject.
Or maybe it's a plain content, right?
Yeah, that's right. I mean, they put that in, I think, knowing Isaac, I'm sure he just thought that was just so funny he had to put it in the paper. So, I mean, Isaac is a little bit like the example given before, where he started his school in Kenya and then he ended up going to boarding school in England. So, again, he's quite familiar with the system, but he didn't finish it. He ended up going somewhere else. Okay, so this is what the regression looks like. And I want to go through these tables because I think now that you guys have seen more regressions and some more research designs, it's kind of neat to see the data. So, column 1 here uses the full sample, 211,000 observations, and has some controls in terms of what district you're in, your gender, and whatnot, and estimates that effect, an effect of 0.294 of a standard deviation in terms of the normalized, sort of standardized KCSE score. Why does that number differ from what we estimated? Yeah?
This number is looking at the entire population of the entire sample. That's not one reason.
Yeah.
So if you imagine just running one regression of that entire sample, you're going to see a different slope that
Exactly. So what's nice about using a very tight threshold, which is what they do in the main analysis sample, which is what they do in the main analysis sample. So let's say they're only in this very narrow range, right? That's sort of what they're doing in the analysis. And then they're basically estimating like a linear regression here and another linear regression here. They don't find really a jump at all. But maybe when you have the full universe of data, so you have just tons more data here, maybe there's a much more complicated relationship between your KCPE score and your KCSE score, and imposing just one linear functional form here means you're almost like erroneously attributing an effect to being in a national school. So it speaks to the advantage of narrowing the window, and that's what they do in column 2. So in column 2, they run the exact same regression with the linear fits on both sides, but now only in this very tight window. And when you get into the tight window, that intercept, the jump you estimate, gets much smaller. It's 0.046. Now that's still not 0. We're going to get to a 0 in column 3 in 1 sec. Why is that might that still not be 0? It's very small if it's 0.046, so why is it not 0? Look at how the variable's defined. That first row says graduate from national school. The second row says admitted to a national school. What is going on there? Yeah?
Is it because the transfers of people falling below the threshold are really close to it, and the actual function?
Exactly. So people here are in the window, but we know some of them actually got into a national school. And what this is suggesting is the people who got into a national school may be a little different than those who were admitted. So, getting in, so this is graduating from national school. So those who graduate are different from those who just are admitted. And maybe it's because some of these guys right near the threshold were just really actually pretty high performing. This is kind of interesting. It isn't like the folks who were just admitted and kind of mess out the assignment do lots worse. They're doing pretty well. So maybe if you're like really ambitious, very good student, and you sneak in, maybe you do slightly better than predicted. So it could be the case that, for instance, imagine some students had a bad day on a KCP test day, and their headmaster of their primary school knows someone in a national school. They can vouch for them and say, this student is stellar, they had a bad day, they were sick that day, they had a family problem or whatever, admit them. And when they admit it, they do okay. The number that's closest, actually the number that is in the figure I showed you before is in this row, which is the dummy for being admitted. The dummy for having a running variable that's 0 or above, and there we just have a 0 point estimate, 0.008. And that was the sort of lack of a jump that we saw before. So column 3 is equivalent to the figure I just showed you. Column 2 says, well, the folks who kind of sneak into the national schools despite their test score may actually not do too badly, if there's a reason why. Okay, then there's column 4, which we're not going to talk about, so I put it in a different color, other than to say that we will talk about IV in a week. And I don't want to bring in all the discussion of IV because you should focus on what's on the midterm. But again, IV, one of the applications of IV is imperfect assignment to a particular intervention or treatment, and this is a good illustration of that. The increase in graduating from national school by having a score above 0, the running variable, is 0.5. That's imperfect assignment, but we can use this data, and we'll talk exactly about how to use this data in a week. Okay, any other comments or thoughts on this table before we go on to the next result? Yeah. Yeah, so column 1 has all the data. The full sample, the other one has the narrow one. So let me actually make it more concrete here. Let me redraw this, but maybe in a better way. So, of course, the test score threshold is really way up here, because only the very good students are sort of eligible. In the main analysis, we're looking at this tight window around the threshold. When we bring in all the data, what they're doing in column 1 is they're just fitting a linear regression, literally linear, on each side. So for some kind of funny reason, when you do that, so the relationship above the threshold isn't going to be changed very much. There are very few observations up here. So let's say that looks kind of the same. Now, when you only estimate this relationship using the data in the window, we saw it looks like that. There's no jump. But if for whatever reason, the way the data works here is something like this. Let's say it kind of is slightly nonlinear, or it looks funny. Then when we fit a linear regression here, it kind of goes like this. And we're getting a jump of 0.294. Because we're fitting a linear regression to something that may be slightly nonlinear. And it's giving us a false treatment effect, basically. But when we're very close to the threshold, we don't have to worry about that. Now, the way people solve this problem when you want to use all your data, and they do it too in their robustness table I'll show you next, is you don't just allow for a linear fit here. You do what we talked about last time, and you allow the outcome to be a function of the running variable squared, the running variable cubed, something like that. And then maybe you would capture this relationship in a way that would give us the right answer. Does that make sense? Okay, I went through it a little too quickly before. Okay, these are the additional specifications. And what they do here is they just basically show you different regressions in the different columns. They add different controls. This third column here is what I just said. They include the third order polynomial. The running variable squared, the running variable cubed. That's the third order polynomial. The one thing you see that happens, always happens with regression continuity designs, is it's not always optimal. You might just say, gosh, let's just include like 10 polynomials. I mean, let's just fit this thing. Let's fit as much as we can. Let's go crazy. But it doesn't make sense because look at the standard errors. If you overfit the data with polynomials, the standard errors have just doubled. So even if I'm reducing bias a little bit, remember we talked about reducing mean squared error last time? If I'm doubling my standard errors, I'm not happy about that anymore. That's not a good outcome for me. So you typically don't want to go down that road. It's better to be able to maybe restrict the sample and use some linear form. I'm not even going to talk about the ideal bandwidth, but there's a formula that's been developed as a function of the data to get ideal bandwidth to get the same answer. And then they use a narrower window. They use half the window, 6,000 observations instead of 12,000. And again, what else do you see about the standard errors? The standard errors actually start going up again. So the optimal bandwidth uses more of the data than this very narrow bandwidth. So this is kind of an interesting table I put on the slide for you guys to review because when you're thinking about regression discontinuity, everybody's intuition is use the tightest possible bandwidth and overfit on both sides. But if you do that, your standard errors are going to explode. And sometimes it's better to use more data and some fitting. And you could actually specify the criteria in advance. You could say, I'm going to pick a bandwidth and a polynomial control set that minimizes standard errors or something. Okay. I have a clicker question here, so I'm going to get to 5 minutes left. And so there's one exception to the no test score effect, and I'll just mention it quickly. People who get in national schools do better systematically on one test, their Swahili test. They do much better, 0.25 standard deviations. And Mbiti and Lucas say there's a very good reason for this. There's actually 2 reasons. One, these are incredibly ethnically diverse schools, the national schools. They're bringing in people from the whole country, and people are going to be speaking to each other mainly in Swahili or English, but not in the language from their region, what's called the vernacular in Kenya, it's the language from their ethnic group. Whereas if you go to a district school or a provincial school, it's much more likely that people are from your own ethnic group, and you would be speaking with them in vernacular rather than Swahili. So that's one reason. The second thing is they actually got some data on how much time is spent teaching Swahili in national schools, and it's actually much more than provincial or district schools. So there's this focus on Swahili as a national language that comes through. So this is kind of interesting because even if people's overall test scores aren't improving, maybe being in a national school makes you feel more Kenyan as a national identity relative to a regional identity within the country. So there could be a payoff that's coming through. So let's just go to RD. We've talked a lot about the RD method. I want to do one clicker question, and I just want, now that we've talked through the different issues, some of these are more or less relevant here, but I want to get your guys' view or your opinion as you think through Lucas and Mbiti and the strengths and weaknesses that we've just gone into in a lot of detail. What are the most important limitations? Is it A, that treatment effects are highly local, which we talked about last time? Is it B, that there are too few observations near the relevant threshold? C, is it that the placement of individuals' test scores is likely to be manipulated? Or is it D, that the KCSE outcome is just too narrow to be of much interest, or is it only of limited interest? Or is it all of the above? So I want to get people's reactions to this. And I think what we've talked about so far, we've kind of ruled out a couple of these and we've emphasized others. So I just want to get people's thoughts. Let's just go for another 15 seconds or something. Okay, so I can see the answers here already, and this is sort of what I thought you guys would say. So, A is the treatment effects are local, and that's certainly an issue. Even though there's some variation, it's still among very strong students. So there's not just one threshold, that's better. There's thresholds from 350 to 450, but we're not talking about the median student who's at 250. These are still very strong students. And then the other point that I thought would come out is this B point, that maybe the KCSE is too narrow, that we want to get at other outcomes. So just in the last couple minutes, let me go through those points. Again, I was kind of emphasizing these. The test score thresholds are still in the right tail of the distribution. Maybe if you were a median student going from, say, a district school to a provincial school would have a big impact on your life. These are already the high achievers that are working really hard and very strong students. Maybe they're already kind of maxing out. Now they're able to exploit some variation, so that's nice, but it's only variation in a certain range. And then the second point is this point that came up very early on that you guys anticipated me by 28 slides, which is great, which is just to say the test score is only one outcome. Maybe if we follow these guys up 10 years later because of the network, because of the name, because of the signaling, because of all the other things they're learning, because they learn to speak German or whatever, maybe for some reason these guys are actually getting much better jobs, or maybe having other types of success even beyond the job sphere that we're not measuring with the test score. So they can't really do it because it's hard to, there's no more administrative data on these guys in some sense, or out of the school system. So that makes it harder. The other thing that would be very interesting is to think about attitudes toward ethnicity, given that if you're in a national school, you're really exposed to people from the whole country, you speak Swahili better. How does that change your political identity and thoughts? And that point was how I was going to link to the Friedman et al. Paper, which is all about how education can help transform political and social attitudes, as we started talking about last time. Hopefully I gave you enough setup in the last 15 minutes of class last time, and you know about the Girls' Scholarship Program enough to get something out of that paper as well. Okay, so I'll see you guys on Tuesday.